Alright, so we have this RC circuit, and we're told to find the voltage as well as the current in the circuit. Alright, so the first thing we want to do is we'll look at the voltage source. V sub s is going to be 10 cosine 4t. So we want to take this 10 cosine 4t, and then we want to take it and put it in phasor form. And to put that into phasor form, we got to note that in this case omega is 4. We'll come back and use that later. Our angle in this case is 0. We don't have any phase shift there. So our Vs in phasor form, so this is Vs here in time, so then our Vs in phasor form is going to be 10 at an angle of 0 degrees. Okay, and this is volts. The other thing we need to know about this problem is that we are dealing with impedances and admittances. So we have both a resistor as well as a capacitor. So we look at the impedance of the resistor, it's just going to be that value of the resistor, and with regards to the capacitor, the impedance of the capacitor, it's going to be 1 over j omega c. So we're going to use both of those in coming up with the impedance for the circuit. Alright, so let's go ahead and write that down. So the impedance is going to be Z equals the R, which is a resistor, 5 ohms, plus the capacitor, which is going to be 1 over j omega c. Alright, so let's just plug in the values we know. So we already plugged in the resistor. Let's go ahead and put our omega. Our omega was 4 and our C was 0.1 farads. We do the math there. Rewrite it. I'm just going to rewrite it here. Z is going to be 5 plus 1 over j 0.4. 1 divided by 0.4 is going to be 2.5, so it's 5 plus 2.5 over j, and as we've mentioned before, 1 over j is just minus j. So we can rewrite this equation again as 5 minus j 2.5. We'll highlight this here. So we got the impedance there as that. Now, the other thing we know is that I is going to equal to Vs over Z. So we know our Vs and we just solve for Z. So we just solve for Z here. So we can say, well, our Vs is going to be 10 at an angle of 0, and then here 5 minus j 2.5. So just like we have in the other problems, we just need to change formats, and it's your preference which format you like to work with. So remember, R equals, it's going to equal to 5 squared plus 2.5 squared. That's going to give me 5.59. My angle is going to equal to tangent inverse y over x, in this case minus 2.5 over 5. That's going to give me minus 26.57 degrees. Okay, so I can plug this into the denominator, substitute that here for the denominator. So we got 10 at an angle of 0 over 5.59 at an angle of minus 26.57 degrees. Okay. The other thing we want, our relationship we want to remember is Z1 over Z2 is equal to R1 over R2. This is the property, and then our angle is going to be angle 1 minus angle 2. That's how we do that. And from here we can rewrite our I. Scroll up a little bit. I can rewrite the I here as so we got 10 divided by 5.59. That's going to give me 1.79, and the angle is going to be 0 minus a minus 26.57, so it's going to give us a positive 26.57 degrees. So we've solved for I in phasor format. Now we just need to put it in time domain. So to do that, let's put it in time domain. And what that gives us is I of t is equal to 1.79 cosine. We said our omega was 4, so 4t plus 26.57 degrees, and this is in amps. So you solve for one part of this problem. The second part now is to solve for our voltage. By definition, V equals IR, or in this case we're in phasor format, so I Z, and specifically Z of the capacitor there. So we know that this is going to equal to I over J omega C. We already solved for J omega C, and we just solved for I, so I is 1.79 at an angle of 26.57 degrees. J omega C we said was 0.4 J. Okay, again, we can do the conversion, or we can look at the real and imaginary axes here. So I can just redraw this here. This is our real, this is my imaginary, and we got 0.4 here, J 0.4, so that means we have 90 degrees there. So I can rewrite this V as 1.79 at an angle of 26.57 degrees over 0.4 at an angle of 90 degrees. Okay, and we use the same relationship of Z1 over Z2 to do this. So 1.79 divided by 0.4 will give us 4.48, and then 26.57 minus 90 degrees will give us a minus 63.43 degrees. And then we want to convert this into our time domain, and that's going to give us, so we're just going to rewrite this here, will give us V of t is equal to 4.48 cosine 4t minus 63.43 degrees, and this is in volts, so that's our voltage across the capacitor in time domain. And based on properties and definitions we've given before, you'll see that I of t, our current, leads the voltage by 90 degrees. So just something to note on the side. I of t leads V of t by 90 degrees. Okay, and this is how you solve this problem. essentially you just need to remember this table, and then very simple math to get both the current and the voltage for this circuit.